Hello everyone, my name is Kasra Edalatnejad and I'm a PhD student at EPFL's Spring Lab. Today I'm presenting DatashareNetwork. This work is a collaboration between EPFL and International Consortium of Investigative Journalists or ICIJ. So let me briefly introduce ICIJ. ICIJ is a global network of investigative journalists which includes more than 250 journalists from over 100 countries. Their most well-known work is the Panama Paper, which exposed rogue offshore finance industry and allowed governments to retrieve billions of taxpayers' money. So let's use this project as a case study to see how ICIJ operates. The Panama Paper started when an anonymous whistleblower leaked over 11 million documents to the organization. Then hundreds of ICIJ journalists from over 80 countries worked on these documents and published stories about them. These published stories resulted in resignation of government officials like prime ministers and senators, and public apology from famous characters like royal family members, celebrities, and footballists. These 11 million documents were already digitalized, but they had many different forms like scanned documents, pictures, emails, PDFs, and Word documents. Handling a large number of documents requires having good tools that allows these journalists to extract information effectively. That's why ICIJ has developed a document management and search platform called Datashare. Datashare is an open source software which is freely available at ICIJ's website. This software allows journalists to process documents and extract named entities such as people, organizations, and locations. Most of the time, journalists are spending their time on tracking and linking these named entities together. ICIJ is already using Datashare as a central service that allows their journalists to search corpora which were leaked to ICIJ. Besides that, journalists can download the software and run it on their local computer to search their personal collection. After a while, ICIJ noticed that there are many documents which are used only once for a single local investigation. However, in our interconnected world, we can see that how other journalists from other countries can benefit from having access to these documents. That's why ICIJ came to us with the problem that can an international group of journalists search each other's documents while keeping their privacy? Before jumping ahead and designing the system, ICIJ performed a survey from their journalists and asked them, are you willing to share your documents? 60% of surveys responded positively, while the remaining 40% said that only if they can have a screening talk with the querier. Based on this, we design our system in two stages. In the first one, a journalist comes to our system and wants to search about an interesting topic of investigation. Then the system performs a privacy-preserving search and finds a colleague who has relevant document about this investigation. In the second stage, we put these two journalists in touch and they can have a screening talk over an anonymous chat room. It's important to note that there is no document retrieval in our system and all document sharing happens out of band. Besides asking for willingness to share, we ask journalists to identify and assess threats in the system. Based on journalists' response, we identified three types of parties: journalists, ICIJ as the organization who runs the software, and third-party adversaries like hackers, corporates, and governments. Journalists trust their peers. To some degree, they trust the organization, and they are mainly worried about third-party adversaries. However, after having a discussion with the ICIJ, we decided to overrule journalists and consider every party as malicious. That's due to the fact that journalists are worried about strong adversaries who can coerce or compromise journalists or the ICIJ through hacking their computers, violence, or legal processes like subpoenas. It's important to note that we decided to consider journalists and the organization as malicious, not because we do not trust them, but to protect them and ensure that they do not become valuable targets for hackers. Now let's expand our setting a bit more. ICIJ has around 250 journalists, but we are considering up to thousands of users. That's due to the fact that there may be future expansions and collaborations. These journalists are scattered around the world, and they have gathered thousands of documents which they are willing to share in our system. Now let's take a look at our privacy goals. First, a querier wants to protect the content of query and hide her identity. On the other hand, a document owner wants to protect the corpus and ensure that the querier learns the minimal information about the documents. And finally, when two journalists have a screening talk together, they want to keep the content and existence of this conversation hidden. This due to the fact that a conversation hints to the existence of a collaboration, which is a sensitive information for journalists. Till now, I told you what we need for this system. Now let's design it. The first challenge that we face is asynchrony. Journalists live in different time zones and they do not keep their computer online all the time. That's why two journalists may never be online at the same time. To handle this challenge, we use a communication server which stores and forwards encrypted messages between journalists. We consider that this communication server is malicious and it only serves us in sending a message to an offline journalist. All communication in our system goes through this server. The second challenge that we face is finding a document owner who has relevant documents. To solve this challenge, we design a document search. As a reminder, this search needs to protect the content of the query, the corpus, and the result of the search. To do this, we design a new cryptographic primitive, which we call Multiset Private Set Intersection. This primitive is an extension of an existing protocol called Private Set Intersection, or PSI. So what is PSI? As the name suggests, it's a two-party protocol between Alice and Bob, which allows Alice to compute the intersection of her set with Bob's. The PSI protocol ensures that Bob does not learn any information about Alice's input, while Alice does not learn anything about Bob's sets beyond the intersection. As I mentioned before, the DataShare software extracts named entities from these documents and represent them as a set of documents. Therefore, the PSI protocol can search one document, which is represented as a set of keywords. However, each journalist holds thousands of documents, and having thousands of PSI interaction is cost prohibitive. That's why we decided to expand this scenario and allow Bob to hold n sets simultaneously, while Alice compute all n intersections at the same time. With aggregating the cost between multiple sets, we reduce the computation and communication costs by 3 orders of magnitude. And MS-PSI protocol can search the whole corpus with one interaction. Now let's integrate this search into our system. A querier creates a query, sends it to the communication server. Whenever a journalist comes online, he retrieves the query, computes a response, and sends it back to the communication server. After a while, the querier retrieves all these responses, processes them, and finds journalists who have relevant documents. The next challenge that we face is enabling a screening talk. To do this, we design an anonymous messaging system. I'm going to skip details and just mention that we use a Diffie-Hellman key exchange to find a random rendezvous point and use post-on-cover messages to allow us to achieve unobservability. If you are interested to know more about this messaging system, feel free to read our paper. Afterward, we combined anonymous messaging and document search and other privacy-enhancing tools that we mentioned in the paper to design the data share network. And now we need to assess its privacy. We do this in 4 layers. First, for MS-PSI primitive, we show that it achieves the same privacy as the state-of-the-art PSI protocols, and use it to show that the document search only reveals information about the search keyword. Besides that, we show that our messaging system achieves unobservability. Finally, we do an end-to-end privacy analysis of data share network and show that we achieve our privacy goals. It's important to note that we are considering a new, stronger setting in which we want to protect a corpus from an adversary who has search access to it. We show that it's possible to provide some degree of protection even against such a strong adversary. However, there are some fundamental limits to document search, which we address in our paper. In conclusion, we performed a requirement analysis on investigative journalists. We designed a new cryptographic primitive, which we called Multiset private set intersection, and used it to design a privacy-preserving document search. We designed an anonymous messaging system to enable us to have anonymous screening talks, and we performed an end-to-end system design and privacy analysis. Even more, we have formal proofs in our extended paper. Thank you for your attention, and if there is any question, please feel free to contact us.